All right. All right, guys, if you could sign in through that URL, that would be great. Yeah, I now realize this is probably a mistake. I probably should have put the URL up before we gave out the pizza. So that will happen next time. We'll get back to the URL at the very end so that you guys can all sign in. All right, so for announcements, the ACM competition is going to be in November 12th at RCC. That's the regional for SoCal. So Cal Poly will have tryouts to determine which teams that Cal Poly will send to represent our school. We can send up to 4 teams, each team being 3 members. The tryouts will occur next Saturday, October 22nd, at the Computer Lab, 8:52 at 10 a.m. Professor Yu Sun will be handling the tryouts, and he will be going over questions, either from the previous year's ACMs or from another site that has practice problems. So what the problems look like are actually here. And what happens is you're basically given a set of 10 questions. They're sort of like interview problems, but they're a little more mathematical. And your group of 3 has to come up with a solution to the problem that can run with a certain efficiency. Like given an input, it must be able to produce the output within a few seconds or so. So you can't just brute force these solutions. So the teams that end up solving the most of these problems end up winning and end up going to the national and world's competition. So Cal Poly has never gone above 20-somethingth place. So the hope is that this year we can do better. So it'd be a good idea to look at this website and practice some of those problems. Let's see. Oh, shit. Okay, so what's good about the ACM? Well, it's good for practicing interview-like questions because if you can answer the ACM questions, you're more than ready to face the interview questions. It looks good on a resume because recruiters are looking for you doing extracurricular activities outside of school, like hackathons, like the ACM programming competition. And certain recruiters from certain companies will give preference to people that do participate in the ACM. One is IBM because they actually host the event. It's also a good opportunity to meet other people in Cal Poly Pomona. And the winning team from the Cal Poly Pomona tryouts next Saturday will receive a $100 Amazon gift card. So, and that was the reason I joined last year. The Cal Poly one, yeah. All right. So there are also Google Tech Talks happening through this week, through the next 3 weeks, and that's why we did not have CSS this Tuesday. So there will be no CSS meetings on Tuesdays for the next 3 weeks. We encourage you guys to go to the Google Tech Talks and learn about their tips for resumes and so on and so forth. The career fair will happen this month on October 27th. So we highly recommend you going to those Tech Talks to help with your resume. Also, Daniel Choi, who is a senior from Cal Poly, who's currently interning at Amazon, will be presenting next Thursday on tips to applying to the Big 4 companies. So we got that to look forward to. But as for today, we are going to be talking about HTTP backends. So does anybody know what an HTTP backend is? Okay, 1, 2, okay. All right, so this is good. So this is the fundamental basic thing you need to know for web development. And web development is now the crux for what a lot of companies are doing and a lot of startups. Because web is a common interface that your mobile phones, your laptops, and your desktops can all communicate through. Okay? So here's a very simple architecture of what a web interface sort of looks like. You have a front end, which your browser renders. But that front end has to communicate with some back end. And the back end is usually a server that has some sort of web server running that hosts the content that can perform your application logic. And that web server also communicates with something called a database, usually. Okay, so the database stores all the important data that you need, that you want to eventually display to the client. Okay, so this is just the very basics. As for the front end, so your website is loaded in a browser from the server, and the front end consists of HTML, CSS, and JavaScript. Those are just 3 different types of text files that your browser loads when you go to a URL. The HTML is just the text, CSS is a way of making it look pretty, and JavaScript is all the client-side code. So what sort of code runs on the client side? Interactive code that determines what happens when you click buttons, in addition to polling the server for updating content, like let's say basketball scores that are live, or more complicated things, like adding things to a database. So the JavaScript on the client side will communicate to the backend, which is just some server that's listening for requests from the client. And the backend has these server-side scripts, which can be run in a variety of different languages, and the backend will then communicate with the database. So this is just the basics of the front end, and this is the backend. Right? So our front end communicates through the internet with the backend through something called an API. An API is an application programming interface. It defines certain resources that the front end can call, and they're basically like functions. The front end calls functions that the back end will run. The back end, depending on the function, will then communicate with the database in some way. After it runs that function, it will return its result back to the front end. So why do we have this sort of an architecture for all of our web development stuff? All right, this is another picture of that exact same paradigm. You have a front end, which is just your HTML, CSS, JavaScript, your GUI. It communicates through an API, making an internet HTTP request to the backend, and the backend will respond with some sort of result, like JSON. And JSON is basically a way of representing an object as a string. So why do we have an HTTP backend? Well, first off, the HTTP backend is just a program that's listening on the computer at a specific port. For most of our cases, that port's going to be 80, because that's where most HTTP traffic goes to. When the program receives an HTTP request, it determines what action to perform based on what resource it was asked for and what HTTP verb it was given. Okay? And this will all make more sense when I show you an example. So you can think of an HTTP request as a way to trigger a function to run on your server. Normally for static websites, all that function is returning the HTML file. Okay? But we're going to use it to create a REST API. Okay? So as an example, so I'm not BSing you. Let's do an HTTP request to www.cpp.edu. Okay, that's our school's website, right? So we're going to do a curl request that's verbose, meaning it's going to show us all the headers that we are sending and that we'll receive in addition to the content on the site www.cpp.edu. And I'm going to pipe it to more. That way it doesn't take up the whole page. Okay, so this is an HTTP GET request. And what you see is that all we send is this text, get /HTTP/1.1. So our verb is the HTTP GET verb. The GET verb, all it's doing is asking to download a resource. What resource are we downloading? The / resource. That's the default resource that we attempt to download if we don't specify a file path after www.cpp.edu. Normally it's www.cpp.edu/whatever, right? In this case, since we didn't have anything, it's just /. And finally, HTTP/1.1 is the protocol that we're using to obtain this. Okay, so this is the host we're trying to contact. Our user agent is curl. Normally it's your browser, like Chrome. And the response we get is this status code of 200 OK. So if everything went fine, we're going to receive 200. And we're going to receive back all the data that your browser normally gets. And it's this giant HTML file, right? So if you scroll down, it's literally a giant HTML file. Okay, that seems to also have the CSS inside it. All right, so that's an example of an HTTP GET request, right? But there's also other HTTP verbs out there. There's things that you might have heard of like post, put, delete, so on and so forth. So let's run through an example of that. So what we use these HTTP verbs for on different resources is to obtain some sort of data that we'll use to dynamically populate the HTML in most cases. So that's the fundamental purpose of a REST API. Okay, so for example, this is an example website. And you can imagine this as basically the API to Reddit, let's say. You have a lot of people, users, that write comments on a website. Right? So what we're going to do is we're going to examine those comments through something called Postman, since Postman's an easy GUI tool to do post requests. Okay? So what are we posting and getting from? Okay? Well, we're getting from this URL, https://JSON placeholder, so on and so forth. So let's do that. And it's saying here, we can do a GET request on this resource, /posts. Right? So let's try that. We're going to do a GET request on /posts. Okay, we send that, and look what happens. We get a result of this JSON. The JSON is an array where the first object has a user ID field of 1, an ID field of 1, a title, and a body. Right? So this was sent back by the web server when we did a GET request on /posts. Okay. So you can use this to dynamically populate your web page, right? If you're supposed to find all the posts that this user made, all you have to do is do this GET request. Your JavaScript will be able to get this information back, and it injects this into the HTML. Okay. So let's do another example. Okay. Let's see. So another example was a post request to /posts. So let's see what the post request does differently. Okay, so all we get is ID 101. Okay, so what these different requests will give you back is dependent upon the API that the developers have defined. Okay, so this website has defined an API where if you do a post request to this, you'll instead receive a different resource. Okay, so these APIs are defined by the developers, and so you'll have to look up documentation for whatever website you're doing your requests on to get what you want. Okay. And similarly, we can do a put request, patch, and delete. So all these different verbs usually have one common meaning. Like I said, a GET request lets you download files from that resource. A post request usually lets you modify those files. Okay? And there's specific things you have to send in the body maybe for that to happen. A put request lets you add content at that resource. And a delete request will delete that resource. Okay. Usually, though, the two verbs that we use most often are get and post. Okay. All right. So as one final example of this, we'll make a post request to this URL, which is actually a server that I have running at my home. And what it's supposed to do is send a list of times that correspond to a YouTube video that summarize the YouTube video. Okay. So as you can imagine, there is probably a lot of work going on in the background in order to find out what times correspond to a summary of a YouTube video. But as the front end, I don't really care. All I'm doing is this post request, and that server magically will return me the JSON that corresponds to the summary of the YouTube video. So I send the post request. I'm getting back all this JSON that says, hey, there's some importance associated with this start time, and a start time here, and a start time here, and so on and so forth. Okay. So the importance of the HTTP backend is to provide an interface where the front end doesn't need to know the actual logic that's happening in the backend. Okay. All right. So why is this useful? The first thing is it lets us do a lot of heavy computation on the backend instead of the front end. Right? We showed you that you can do client-side code with JavaScript, but if the code takes a lot of time to run, or you don't want to have state on your clients where your clients can modify that stuff, you have it in the backend. Okay. So the other thing is it provides a level of indirection between the client and your own internal services like your database. Right? So if you didn't have the web server there and you had all your code run on the client machine on the JavaScript, and your JavaScript could directly call your database, well, now your users can completely muck up your database. They can insert random stuff. They can delete stuff. And if you're like, let's say you're a bank and your database holds all your customers' credit card information, this is unacceptable. So the backend is a gateway that funnels all your front-end requests and makes sure that you can only do these certain things. And how it relates to us is when we're creating our parking app, we want to have a web server that provides this interface in order to find out all the parking data. So what's going to happen is we have a backend, that's our web server. We're going to have three different types of front-end clients. One is your normal computer loading a website. The other will be maybe an Android app or an iOS app, they'll all communicate through that common REST interface on a web server. And a web server will have the information from the number of cars in each parking lot through all the Raspberry Pis that are sending information to it. Are there any questions about this architecture? Okay.
With the Pis communicate through this.
Yes. So the idea is the web server's API should have resources that allow the Raspberry Pis to post requests to it to update the counter that stores the number of cars in the lot. And then we'll also have another resource where these clients can get requests or to just get that. That's like that's a good question. That's a good example of where we differentiate between get and post. Here we need to view the data. Here we need to modify the data. Okay. Are there any other questions? All right. So we already touched on this, but another reason why this is useful is because it provides an interface so that allows you to develop all these other different types of front-end apps that just depend on the interface. Right? All right, so how do we actually make an HTTP backend? It's actually a lot of work. You have to have a program that is constantly listening on some port on the computer. It's got to be able to take maybe thousands of requests that are coming simultaneously from all these different clients. And it's got to be able to do some work and then send its answers back to all these different clients. And if you want to do this very efficiently, you might need some multi-threading, or you might need some sort of event dispatch loop. And it's very difficult, right? So what we do is we don't build it ourselves. We use a library or a framework that handles it for us. Okay? So these are some example frameworks. For Java, there's something called Spark Java. There's also Play, and there's also Spring. For Python, there's Flask and Django. For JavaScript, there's Node, and JavaScript I would shy away from because it's not the best language to use. Although it has become the most dominant language on the front end and is the most committed to language, it's got a lot of nasty things like type coercion. But we'll get to that. For Ruby, there's Rails, and for Swift, there's Vapor. So for this class, we were considering using Java as our backend, but since we all are learning Java from Cal Poly. But for the sake of quickly developing stuff, it's actually much easier to use Python. Python is extremely concise. And although it runs slower than the JVM, it's very easy to prototype something useful very quickly. And I'll show you that today when we compare the two. Okay. All right. So let's actually get started by developing our own HTTP backend that will eventually be able to take some requests. All right. So let's open up an IDE. Let's see, let's create a new project, and we'll do it in Python. Oh, the screen is... Yes, apologies, the screen is pretty weird up here. Okay. Actually, let me just create the project on this side and then drag it over. Okay. Okay. So all I did was create a project. Okay, that has nothing inside it. These are just IDE files that aren't relevant to our project. All we have is basically a folder, right? So let's create a new file. Let's call it application. And what we're going to do is we're going to import Flask, the library. Okay. So actually, we're going to import this statically. So from Flask, import Flask. Okay. And the reason why the IDE is yelling at me is because I haven't installed it. Okay. So you'll find that for a lot of common libraries that you're going to need, if they're not part of the language's standard library, you're going to need to import them, download them somehow. For Java, you usually just download a jar, or you use something like Maven or Gradle in order to download them for you. Okay. For our purposes, since we're using Python, we'll use something called pip. So we'll do pip install Flask. Oh wait, sudo. Okay. So we have Flask, And now the ID is not complaining anymore. We've got Flask. Okay. So all we do is create an application object by initializing it with Flask. We pass it the name of the file. Okay. And then we write our main check. Basically, this is equivalent to public static void main. Okay. We're just checking if we're in the main method. And if we are, then we'll run the application. Right. So that's it. That's all it takes to create your own web server. Okay, just those few lines in Python. It takes far more in Java, and for a complicated enterprise app, way more. Okay, so this is why I would encourage you guys to learn Python because it's very versatile. It lets you prototype really quickly, and it's also a valuable resource to be able to understand multiple languages. Because once you get out to the real world and industry, you're not going to be programming Java necessarily. You're going to have to learn new languages on the fly. And moreover, our OpenCV is probably going to be using Python. So let's run this application. And what happens is you'll see it says it's running on 127.0.0.1:5000. So this is a URL. Right? We mentioned this on the first day earlier. But what this means is that it's using the HTTP protocol. It's listening on port 5000, and this is the IP address it's listening on. 127.0.0.1 is a special IP address that is localhost. Okay. And when we go to that IP address, it says there is nothing found. Okay, that's because we have nothing there for it to display or return. Okay, so let's add something to that /endpoint. Okay, so what I'm going to do is I'm going to define a function, and this function will be called when we do an HTTP GET request on /. Okay, all I'm going to do is going to return return the string hello world. Okay, but the application doesn't know to call this method when I invoke /. Okay, so in order to do that, I'm going to add this decorator app.route /, and now it knows that whenever an HTTP GET request is sent to /, this function gets called. Okay, so let's see what happens if we try rerunning this. Right, so we refresh the page, we'll see hello world. Okay, so there we see our basic concept of how this works, right? So we can do something like a curl request to 127.0.0.1 :5000, and we'll see hello world, right? Now everybody can interact with my application. All right, so what exactly is 127.0.0.1? So if we look at something called the etc hosts file, this maps IP addresses to or host names to IP addresses. Okay, so every single computer will refer to localhost as 127.0.1, and it's basically a way of telling the computer to talk to itself. Okay, if I wanted to talk to a different computer, I would have to put in that computer's host name, like Google.com. Right? Okay. All right, so let's make our application a little more interesting, right? What ways can we make this a little more interesting? Well, HTTP GET requests have something called URL parameters, right? So let's take an example of Google, right? So we go to Google and we search hello world. Okay, you'll see that the URL is much longer now. Let's see. Well, I'll just paste it here. Okay, it's got all this stuff, right? You still see the basic parts, the protocol, host name, but now and this is your path. It's just /search. Okay, but what's all this stuff after that? The question mark, the key, and the ands. Well, this is basically a dictionary of key value pairs. Okay, so everything following a question mark on a URL is something called URL parameters. Okay, everything afterwards is a set of keys, followed by an equal sign, followed by a value, followed by an ampersand, and then another key equals value, and key equals value, and key equals value. So in this case, the value for source was the empty string. Or actually, sorry, it was HP. Oh, sorry. The value for site was the empty string because we immediately see the ampersand sign. Right? Does that sort of make sense to everybody? Okay, so let's make our application do something slightly more interesting. Instead of returning hello world, let's return whatever the value was for the URL parameter key hello. Okay, so in order to do that, we return so we need to import request in order to be able to obtain a request object from the client. So from Flask import request, and we're going to return the request dot args. So this is the URL parameter, and let's say on hello. Okay. So if we rerun this, okay, if we go back to localhost 5000, what do you think is going to happen if we type just slash here? Right, because there's no path for it, or actually it will attempt to call root, but it'll try running this code, but there was no arg hello passed in the query string, right? So it's going to crash because this is basically a null pointer exception. Right? So if we do add so slash then question mark hello equals bye, what do you think is going to happen? Yes, let's see. Well, we have to restart it actually. Let's see, did I do this wrong? Turn request on. Oh, my bad. There's also a get here. Yeah. Oh, there we go. Okay, so it's not important to memorize exactly the syntax of how like Python Flask does it or maybe Spark Java. The idea is that all frameworks will allow you to access these URL parameters in some way. Okay, and what you'll do is you'll probably on the job look up documentation on like when you need to in order to determine what methods you need to call. Right. So stuff like this. Yeah, you'll look at just stuff like this in order to determine what to code. Okay. All right. So that was something called the URL parameters, but that's only for a post for a GET request. How do we handle something like post requests? Okay. Well, all we do is we modify this decorator with another parameter called methods, and we define all the methods that this function should run on. So those HTTP verbs. So here we'll let it run on both get and HTTP get and HTTP post. Okay. So actually, let's do it only on post. Okay. So when you looked at Postman earlier, when you do a post, there's things that you can add to the post request. You can add these things called headers, right? And the headers are what you see here. Let's see. These are the HTTP headers. So you can manually add those in when you're requesting stuff with Postman. But for post requests, you can also send a body. Okay, this is the data that you want to send in order to update something. Right. So in this case, all the body is just key value pairs. Let's add a key of key, and let's let our value be hello. Okay, or let's do it here. Yeah, or hello world. Okay, so since this is taking a post request, we now need to get the request body's form. So we do request.form, and here we examine the key hello. Okay, so let's rerun this. Okay. So what happens if I were to send this post request? Yes. Yeah. So you'll see world, right? So if we change this, it should now say hello back to you, and it does. And you see here that the logger actually picks up those two post requests. Okay. And we can also send over other things like raw data or binary data, and this is how you upload stuff like files, like images. Okay. All right. So that was a basic overview of how HTTP backends work and with Python. So let's actually try something with Java, since you guys are more familiar with Java, and you probably will start with Java since you're more familiar with it. So let's create a Java project. Let's see. I'm gonna have to move this to the side when it creates a new thing. Let's see. Okay. Oh crap. Okay. So we just created a brand new Maven project. Okay. So Maven is a command line tool that lets you organize your Java projects in a certain way, so that's easy to import libraries that you find on the internet, and it's easy to deploy your application after you compile it into this one binary jar. Okay. So what makes a Maven project look different from a regular Java project? Well, there's still the source folder, but you'll now see there's two folders, one called main and one called test. You'll put all your testing code here, and what testing code is basically code that verifies that your methods are correct. So when you work for a company and they write code, you have to write testing code to make sure that your code actually works. Okay, and this usually gets run whenever you build your code, and if the tests fail, then your source code doesn't get pushed to the web server, let's say. So this is a way of ensuring that your code is running and it's performing correctly before you do updates to your clients. The most important thing about Maven is this POM file. It's an XML file that specifies, this is basically what your project's name is, but this is also how you're going to import all your libraries. Okay, so we're going to import something called Spark Java, which is similar to Flask, but it's written in Java. In order to import this, we need to add this dependency to our POM file. So what I'm going to do is I'm going to copy it. I'm going to create a dependencies XML element. Okay, and then I'm going to copy paste that dependency in there. Okay, I'm going to enable auto import, and so whenever I import stuff from Spark Java, it'll automatically download the library. Okay. So let's create a Java class. We'll call it testing. Write a main method, and let's see if this actually works. Okay, so they're saying all you have to do is import Spark, and you can do a GET request this way. Okay. So we're going to import. Let's see. Let's first do the import. Import Spark dot star. Okay, and now we have a GET request on /hello that'll return the string hello world. Okay, are any of you guys familiar with Java 8's Lambda syntax? Okay, just two. Okay, so there's a concept called a Lambda function, which is basically an anonymous function. It's basically functions that you can pass around. But we're not going to go into the details of that. So instead, we're not going to use Lambda functions here. We're going to just create an object here. And basically, this is the function that essentially gets run when you get past hello. Okay. So in this case, we're going to return the string hello world. And let's see what happens when we actually run this. So if you'll notice, this POM file allowed me to download those libraries to here. If I didn't have this in my POM file, none of this would be downloaded, and this wouldn't run. Right? So let's see what happens if I comment this out. And I try running this. All right, it's going to fail because it doesn't know where this library is. Okay, but if I had this in my POM file, Java will magically, or Maven will magically know how to download that library and then add it to your class path for your project. Right. So let's run this again. Now that I've uncommented that, and you'll see. Oh, this is a standard error message that happens when you're using the Java logger. But this should be running on port 4567. So let's do that. Let's go to localhost 4567. But we get a 404 because there are no paths defined for that resource. We've only defined the path for /hello. So let's go to /hello, and there you get hello world. Okay. So Spark Java is one of the more lightweight HTTP server libraries. There are others that are much more heavyweight, like Spark or like Play and Spring. But generally, Python is the easiest to get started with this sort of stuff. Are there any questions? All right, that's pretty much the basics of HTTP backends. Next week, we're going to have Daniel presenting, like I said, from Amazon. He's going to probably call in and do a presentation. The week afterwards, there will be no CSS meeting because of Fall Career Fair. And then the week following that, we will likely have two team leads from JPL to discuss internet architecture with Docker and Kubernetes. So that's the way that you architect your entire services structure in the backend. But before that, I'd like to have.
You're not gonna. You're not okay. I'm not gonna come. Okay, Chris, you're coming up. My name's Elise. I'm a mechanical engineer, and I am the project manager, or one of the project managers this year for the Northrop Grumman collaboration project. And like you were saying earlier, with your ACM competitions and all your extracurriculars and whatnot, getting your actual practice within your major, I just want to present on another option for you all. So the Northrop Grumman collaboration project, it's a pretty large project, totally funded by Northrop Grumman, a potential company you could work for in the future. But we have 5 vehicles that are all unmanned, and they're all a system with one another and communicate with one another. I have my ground control station lead here today, Chris, who's one of your own. And maybe he could talk about more of the actual CS applications than I would, because me being a mechanical, he'd probably speak to it more.
So there are like 5 vehicles, and one of the things that's actually visually shows all of them on data on the monitor is the ground control station, which I lead. And so we use C#, C++, Java a lot to program all of our backend stuff. So we need CS majors to have like at least 1 year. What are we looking for?
Honestly, if you want the experience, come. Because you can come with having 0 of your CS classes done, or even, going through them. And we have a lot of upperclassmen that are willing to teach you and help you learn through the experience on the project. So everyone should come.
It's a really great opportunity. That's where I really learned a lot of hands-on ways to do projects and stuff. And so it would help if we have juniors and seniors to be there and who actually have experience, and we can get you up to speed. And then we also need freshmen and sophomores to train them for the future years to come, because we need a steady flow of CS majors to make sure we keep everything sustainable.
Exactly. Because this is the 6th year of the project, I believe, right? So this project happens every single year. So this could be, experience for the rest of however long you're here at Cal Poly. I only have a year left, but I've been on it for 3 years, and it's been really instrumental in my learning, because I've learned some things on the project before I even ended up learning them in my classes. So it helps balance and, bring together all the understanding you're getting in your coursework. Even though I am a different major, I feel that is still transferable and applicable to your own majors as well. And it's a collaboration project. So, I'm a mechanical, he's CS, we have aerospace, we have electrical engineers on the project, we have business majors, we have industrial engineering majors doing more of the managerial and accounting work. So it really is like you're working in a little company, and you're given certain tasks, and they interface with other portions of the project, and it helps you learn how to work with other people, work in a team, as well as, build your communication skills in having to present to Northrop 3 times a year, getting that FaceTime with them. We always provide resumes to Northrop Grumman for members of our project as well, so that's another avenue, and it just looks amazing on your resume. Just as he was saying about the ACM competition, all those kind of extracurricular activities, they really do set you apart from the other Cal Poly Pomona graduates within your major, because hopefully we're all going to graduate, we're all going to get our degree, but these little experiences, they fulfill and enrich your knowledge of your subject so much more. So I would really encourage it. On the back of the pamphlet, I don't know if they've gotten all around, but on the back of it, it says it has information on our kickoff meeting. So our kickoff meeting is going to be this Saturday from 9 to 12 in Building 17, room 1211. On there, it says the room is to be determined, because we weren't sure of that yet. So if you have a pen and you want to write that down really quick, it's Building 17, room 1211. So it's right underneath the stairway. yeah, come on out. It's just going to be an info session so you guys can understand more of like what we do on the project, where you might be able to fit in, and you know, any kind of questions you'd have, come on and bring them. Chris will be there. And Dr.
I
Tang.
want to add something about the project. So I'm the CS advisor on that HCP project. So basically for CS students, in addition to get this really good